Hi guys, this is your teacher Xingyi from Sync Academy, and welcome to our Day 5's daily challenge, which is about similar triangles, which is a very important part in geometry, as well as the prerequisite knowledge for the future incoming Algebra 2 learning. Okay, so in today's daily challenge, we have 6 questions in total, and for the 6 questions, we cover about how to prove similar triangles and the basic properties of the similar triangles. And let's see the questions one by one. So the first one, we have the triangle ACP similar to the triangle ABC, and we have the length of AC, which is 6, and AP, which is 3. We need to get the length of the AB. Okay, so since we know that the triangle ACP similar to the triangle ABC, we can therefore have the AC over AB equals to AP over AC. So we have AC equals to 6 equals to AB, and AP equals to 3, and AC equals to 6. Okay, so we can have AB equals to 12. So the answer is 12. Okay, so this is a question about the basic properties of the similar triangles. Okay, we have the size proportional. We have the pairs of size be proportional. Okay. And then the second question, which of the following conditions below can be used to deduce that the triangle ADE is similar to the triangle ACB? Okay, so before that, let's have a quick recap of the 3 ways that we can prove the triangles are similar. Okay, so here we know that we have this angle, the angle A, it belongs to the triangle ADE, and it also belongs to the triangle ACB. So, and if we have 2 pairs of the corresponding angles are equal to each other, then we can have 2 triangles are similar. So now we only need to have another pair of the corresponding angles are equal to each other, then we may have these 2 triangles are similar to each other. So if we have the angle 2 equals to the angle B, then we can therefore have the angle, so which is the angle DAE equals to the angle CAB. And if we also have another like angle 2 equals to the angle B, we can also know that these 2 triangles are similar to each other. Okay, and we can also have the triangle like 1 equals to the triangle C, but there is no such choice, so the only correct one would be C. Okay, so we have actually 3 ways to prove triangles are similar. So the first one would be AA, which is this one. We have 2 pairs of corresponding angles are equal, and if we have 3 pairs of the corresponding sides are proportional, that would be SSS, another way to prove triangles are similar. And also if we have 2 pairs of the corresponding sides are proportional and the corresponding angles between them are equal, which is SAS, it's the 3rd way we can prove 2 triangles are similar. Okay, try to remember the 3 ways when we need to prove. Okay, so let's see the 3rd question. We have the square ABCD, so E is the midpoint of AB, which means that AE equals to EB, and we also have the AF perpendicular to DE at point O. Okay, now we need to get the AO over EO. So we can prove that AOD similar to the triangle EAD, since we have the angle ODA, which is actually the angle ADE. So actually they're the same angles. And we also have the angle AOD equals to the angle EAD, just 90 degrees. Since we have the AF perpendicular to DE, and we also have the ABCD is a square. So we can prove that the triangle AOD similar to the triangle EAD by AA, okay? And then therefore, we can have the AO over EO equals to AD over AE, which is 2. So the correct answer is 2. The first question, we have the triangle ABC, and we have the angle C equals to 90 degrees, and D is AC, and we have the DE perpendicular to AB at point E. So if we have AC equals to 8, and BC equals to 6, and AD equals to 5, what's the length of BE? Okay, so since we have DE perpendicular to AB, we can have the angle AED equals to 90 degrees, and in the right triangle ABC, as we know, the length of AC is 8 and the length of BC is 6. So by the Pythagorean theorem, we can have the AB equals to AC squared plus BC squared, and have the square root of it is the length of AB, which is 10. And since we have the angle A equals to the angle A, and we have the angle AED equals to the angle C, which is 90 degrees, we can know that the triangle ADE is similar to the triangle ABC by AA. Okay, so therefore we can have the AD over AB equals to DE over BC, so which is equivalent to 5 over 10 equals to AE over 8. We can then have the AE equals to 4 and BE equals to 6. So choice D for this one. Okay, and the fifth question, we have the DE is the median of the triangle ABC, and F is the midpoint of DE. So if the extension of BF intersects with AC at point H, then what's the AE over EC? Okay, so we have, since we have the DE is the mid segment of triangle ABC. We know that DE is parallel to BC, and also DE is 1/2 of BC. Okay, and we can have the AE equals to EC correspondingly, and since F is the midpoint, of DE, we can therefore have the EF as 1/2 of DE, and as DE is 1/2 of BC, so that would be 1/4 of BC is EF. And so we can have the HE over HC equals to EF over BC, which is 1/4, and therefore we can have the HE over EC equals to HE over AE, which would be 1/3. So choice A. And the sixth question, which is the last question, we have the triangle ABC and the D and E are on the AB and AC respectively. We have the DE parallel to BC. So this is very important point for this question. And M is a point on BC that's not coincident with B and C. And AM intersects with DE at point N. Okay, so SDE parallel to BC, we can then have the angle ADN equals to the angle B, and we can have the angle AND equals to the angle AMB. We can have the angle ANE equals to the angle AMC. We can have the angle AEN equals to the angle C. Therefore, by AA, it's really easy to prove there are three pairs of similar triangles. So respectively, there are triangle ADN similar to the triangle ABM, and the triangle ANE similar to the triangle AMC. Okay, and the bigger one, that would be the triangle ADE similar to the triangle ABC. Okay, and therefore, the only correct choice would be C, since we have the DE over BC. So in this pair of similar triangles, we can have it equals to AE over AC, and in this pair of similar triangle, we can have the AE over AC equals to NE over MC. So the crossing method, we can then change the numerator and the denominator here, so that would be DE over NE equals to BC over MC. So C is correct.